everyone, myself Marin Sarah Thomas. Today I'll be presenting on my project Network Intrusion and Prediction using Machine Learning Models. The cybersecurity threat like denial of service, remote to local, user to root attack pose a major risk. The goal of this project is to build a model that can accurately detect this type of intrusion using machine learning model. We start by importing the required libraries. Here I have chosen NDT dataset for the network intrusion and prediction. So here I download the dataset from my Google Drive. Here I load the dataset using the pandas and CSV file. Next, I define the column name manually as per the NDT dataset specification and assign to the data frame. In the next step, I have combined the training and the testing data. Then I checked for the duplicate and null values and handled it. So in this step, we are checking for the duplicate values and handling it. So the final dataset contained 1,47,905 and 42 records. Next is the visualization of log transform duration feature. Here we visualize the distribution of duration feature from the dataset by applying a log transform, then plotting a histogram with a kernel density, estimate the overlay. The transformation helps to reduce the skewness caused by large outliers and brings the data closer to the distribution. Next is the blocks plot of log transformed SRC bytes and the DSC bytes. This visualizes the distribution of the SRC byte and DSC byte feature using a blocks plot after applying a log transformation and NP log to compress large value range and handle zero values. So this is the output. Next is a count plot to visualize the class distribution. This visualizes a count plot to see the distribution of different classes in the dataset, which is to handle the class imbalance more clearly. The next step is the pre-process of the dataset. Here we map the attack types into broad categories. In this step, we simplify many specific attack types into 5 broad categories: denial of service, probe, remote to local and user to remote, and normal. We use a dictionary called attack map to group attack based on their nature. Next is the data pre-processing for model training. First, we identify and encode categorical features like protocol, service, and flag using label encoder to convert them into numeric format. And we check for the null values and use mean imputation on numeric column to ensure the data completeness. And In the next step, we separate the features X and target Y, and we divide the data into 80% training and 20% using the train and test split. Then we use standardized feature using standard scalar to bring them to the same scale, the encode class label to numeric value for the model compatibility. Next is the autoencoder for feature compression. Here we build an autoencoder with 64, 32, 64 output layer using the ReLU and sigmoid activities, and we train the data on scale data to minimize reconstruction loss, and we use encoder par to compress the high dimensional feature into low dimensional for the further modeling. So here we have used 50 epochs, so it will take some time to run. So by the time we talk about the models, so here I have chosen a random forest classification model. I trained the random forest model using the autoencoder feature. The model achieved high accuracy and handled the imbalanced classes better due to the class weighing, and also visualize the ROC and the confusion metrics. So I have got an accuracy about 99.19%. This is a ROC graph. Next, I trained the XT model on the same autoencoder feature. The XT boost is powerful for structured data with label encoding, and it also provided a good performance. For this, I have achieved an accuracy of 99.25%, and this is the classification report, and this is the confusion matrix. Next, I have used an light LGBM model. It's an another gradient model, gave the best overall performance, and it achieved an accuracy of 98%. Next step, I have done a model comparison to find out which model is better. Then I find out that the X-ray boost gave the best performance and it have an accuracy of around 99.25%. To complement the classification, I also performed a regression analysis using random forest regression to predict the intrusion numerally and gave a useful insights. So this is the insights I get from the linear regression model and random forest. Then I used an unsupervised model. So I have used a DP scan model because it can find the cluster of verifying sites and it can handle the out noise and the noise effectively. So this is the result I have got. So in future I plan to extend the model to real-time intrusion detection and experiment with LSTM and encoders. Thank you.